For a while now, tRPC has been my go-to for building full-stack TypeScript applications, but I've decided to abandon tRPC. Now, tRPC is a great library, don't get me wrong. It basically pioneered end-to-end type safety, primarily through type inference, which felt magical. No code generation needed, no introspection, nothing. Just write your code. But after working with it for some time, I started noticing some issues with runtime safety. The thing is, tRPC uses a transformer, which is generally superJSON, to handle serialization across the wire. Now, this creates a kind of separation, a gap between your validation schemas, maybe you're using SOD for instance, and the actual serialization and deserialization happening via superJSON. Now, I know you can define output schemas on the server, which is great and recommended for catching bugs early or making sure you do not accidentally leak sensitive data. But here's the problem. The client side doesn't use those schemas as runtime guardrails. It basically just accepts anything that superJSON can successfully deserialize, whether or not it actually matches the data shape that you're expecting. And that's if you're using schemas to begin with. If you infer everything, then that's even worse. The compile time type safety is super nice, again, don't get me wrong, but I found myself really wanting two things. The first one, stronger guarantees that the data hitting any client actually matches the expected structure at runtime. And the second one is more flexibility. For what? To handle custom data types beyond what superJSON offers out of the box, without having to define your own, which has always felt very clunky. Now, aside from that runtime safety aspect, as my projects evolved, I started craving more in general. I found myself searching for a solution that offered first-class, type-safe error handling. I wanted errors to be explicit values that I could handle predictably, not just unknown exceptions flying around. I also wanted built-in, effortless telemetry. Integrating OpenTelemetry shouldn't distract me from the business logic. I wanted more powerful and predictable concurrency. I needed a very comprehensive approach to concurrency. So bounded versus unbounded concurrency, batching, semaphores, mutexes, latches, the whole package pretty much. I also wanted type-safe dependency injection. So managing dependencies effectively, having constructors where I could apply retries and fallbacks. I wanted dependencies that were aware of their context and life cycle, all of that without any complex boilerplate. So pretty much effortless dependency injection too. And finally, true composability. The ability to snap together small independent pieces of logic to build complex features or complex behaviors that were still easy to test and also to reason about. And that's where Effect and its AddEffect platform packages come into the picture. Now, a huge part of what I'm going to show you is Effect Schema. So if you come to the website of Effect and scroll down, you'll find this section on Schema. And this library is incredibly elegant and powerful. It's the best one I've used out there. Unlike maybe SOD or other validation libraries, Effect Schema is designed to be bidirectional. What does that mean? You use the exact same schema definition to both encode data and validate it on the server side and to decode and validate it when it arrives on the client side, all happening at runtime. So the cool thing is, this means the contract is truly met on both ends, giving you full runtime safety. And because Schema is fundamentally a schema definition library, you can define complex or custom data structures. So things like hash maps, hash sets, specific date formats, whatever you need, and you are rest assured that it's going to work across the wire. So the plus is that it is way more predictable compared to a separate layer like SuperJSON for those transformations. And it's also a very composable library by nature. So for this, I built a to-do application as the demo for how everything would tie together. So the front end with React and the backend with Effect Platform, specifically the HttpApi modules. So here I can create a to-do, so do the dishes, I can mark them as completed, I can delete them, everything you would expect in a simple to-do application. And all of this is being persisted with a Postgres database. Now, the nice thing about the HttpApi module is that it doesn't use a custom protocol or contract like tRPC does. It's just a traditional REST API. You have consumers that are not in TypeScript, don't worry. You would consume it as you would with any other REST API, which is a huge plus compared to tRPC. And not only that, since Effect offers telemetry out of the box with basically one-liners, as you can see, I'm running a local Jagger instance and I can visualize all of the traces, and so we can see the timings, the children spans, everything, which is obviously a must-have for any production application. So now let's go over the code and see how everything ties together. So for this, I have your usual PNPM workspace monorepo, where I have 4 packages. I have the client, the database, the domain, and the server. So here in the domain is where you define the API contract. So if I come here under API, I have this contracts file where we re-export all of the contracts as named namespaces for both our client and the server. But if I come here to to-dos contract, you'll see that we have a group. So we say export class group extends HttpApi group.make, and then we pass in an identifier. So what is this identifier? This is just like the helper for us to be able to map in code whenever we consume a contract in an ergonomic object-like API. So pretty much like tRPC, where you start defining the procedures and the groups, same thing. But in this case, you have to do it a little bit more manual. So you need to specify the identifier like this. And then once you have this group, you can start adding endpoints. So you can say HttpApi endpoint and then .get. And same thing, you specify the identifier. So you get these API client.todos.get API, but you must also pass in the path. So this will be in the root. So notice how this already differs from tRPC. Since it's just your usual REST API, then you need to specify the HTTP metadata, so that if you have a client that isn't in TypeScript, you can still hit it without any special treatment. And now here you can add success. So you can say this will succeed with an array of to-do. So notice how everything is at runtime. This schema right here is what the server and the client will both use to decode and encode. And then you can add a post endpoint. So same thing, create, and then the path, and then you can say add success. This will succeed with a to-do, and this requires the create to-do payload. So notice how all of these schemas again are defined at the runtime. So a to-do is comprised of an ID with a to-do ID, which is a nominal type, which Effect gives you for free. So if I come here, as you can see, it's just a string with a branded type for better developer experience. Then we have the title, where we're going to trim the title, and we're going to apply a filter. So it must be a non-empty string. And finally, we have completed, which is schema.boolean. And so the create to do payload is just the title. So we can extract the fields from this to do, and then we can target title, completed, ID, etc. Just so we do not have to duplicate everything. And with that, all of these, as you can see, are synchronized with the base to do class. And this endpoint will now validate against this schema. And it is also going to decode it. So you can apply transformations to the title, for example. And then here we can also say put, so this will be an update. And here we can add errors. So we can say this endpoint is expected to fail with a to do not found error. Now you might be wondering, what about internal errors? Do you need to model that? No, of course not. Internal server errors and the like are assumed by default. These are just domain errors, basically. So here we can say to do not found error, which is simply a schema.tagged error. And here we pass in the identifier and then the tag, which is usually the same thing for both. And then you can define the fields. So this error will have a message property of type string, and then we can apply some annotations. So for example, this error will represent a 404, and this is super nice because errors are serializable too, because ultimately Schema is handling all of this bidirectional nature for us. So it's super streamlined and also straightforward to use. And then here we say this will succeed with a to do, and this requires the update to do payload. And finally we have the delete one, which is the same thing. We have add error, add success, and then set payload. And all of these will be prefixed with /todos. So again, all of the HttpApi metadata. And that's it. Now you can create your domain API. So this is what both the client and the server will consume. So the root, basically. So you say domain API extends httpApi.make, and then you pass in an identifier, and then you can add all of the groups. And you can also add middleware, for example, so .middleware, and then you can pass in the global rule that must enforce that the user is authenticated and whatnot. Now, the reason you must pass in an identifier for this domain API is because you can have multiple APIs. You could have the domain API, which is like the public API, while you could have a private API that lives internally in the server. So think of webhooks and the like. Anyway, with this, you can now come here to the server and come here to API.ts, where we do the same thing. Export const API is equal to httpApi.make, and then we add the domain API. Reason being is the server might have more APIs to implement. So I would recommend modeling it this way, and then once you need to have an internal or private API, you can simply say add HttpApi and then your internal contract. And with this, you can now come here to the server and you can say API live, so the live implementation for the contract. And so you must specify for which API. So we say for this API, and then this will require us to provide the live implementations for all of the groups. So basically for the whole contract of the API. So if I remove this, as you can see, we're going to get an error here saying, hey, you need to provide the live implementation for the to-dos group. But all of this is also tracked at the type level. So as you can see, this API live requires an API group for to-dos. If I uncomment this, as you can see, this goes away. And now this will require the database client because to-dos live requires the database client. Anyway, if I come here to to-dos live, this is where your actual live implementation of the procedure lives. So you can say HTTP API builder, you specify for what API or this API defined by the server, and then for what group name. So here, as you can see, you get type safety. So it says to-dos is the only group that you can implement. So once you choose it, assuming you might have more than one, then Effect will narrow down the types for you and will know that you need to implement the handlers for the to-do group. And now here you need to pass in a function, which is like the build for this live implementation. And so you get the handlers as the first argument, which is simply a type-safe and very developer-friendly way of ensuring that whatever it is that you're implementing conforms to what the contract expects. And so here you can access a repository, your service, etc. And all you need to do is say return handlers and then handle each one. If I remove one, for example, we're going to get a type error saying that we're missing the delete endpoint, as you can see here. And again, everything is tracked via the type system. So as you can see, when we want to create a to-do, this request will contain the payload, which is the create to-do payload. So here we can access the title. And again, we can instrument everything with one-liners. So effect.with span, and that's it. You have full parent to child relation, error tracking, attributes, and whatnot out of the box. Now, what's super powerful about this approach is being able to track the errors at the type level. So if I come here to, for example, delete, you'll see that we remap a no such element exception to a to-do not found error. And if we were to fail with something else, so for example, let's change this to new error, you'll see that effect will tell us, hey, you cannot fail with error. The only thing you can fail with is with a to-do not found error, which forces us to convert those actionable errors into defects if the contract does not expect those errors, which is super, super nice. As you can see, I can revert this and well, everything works. This means that the client is aware of this error, again, which differs from tRPC and the like. Now I'll not dive into this particular implementation, so make sure to clone the repo and play around with it. Try to understand how everything ties together. Anyway, if I now come to the client, so here, packages, client, then source, I have this data access directory. And this is how I like to organize everything in the front end. So I like to encapsulate the data access logic within these namespaces. So it's super easy to share and whatnot. But here we have all of the queries and mutations. And all of this uses TanStack query under the hood. There's no lock-in, nothing. You can use whatever library you want. In my case, I created wrappers for TanStack query. So I created a useEffect mutation wrapper, a useEffect query wrapper, and a useEffect infinite query wrapper, just to reduce boilerplate and add some really nice utilities exposed in the arguments of the hooks. Anyway, here we can say flat map and we get access to the API client. And then here, as you can see, we get these dot notations. We can say client.todos and then create, delete, get, update. And if I do get, as you can see, it doesn't expect anything. And now, if I hover over useTodos queries, as you can see, it is going to succeed with the todos contract.todo. Now, what is this API client? Well, this is just the live implementation that communicates with your server. So again, since everything is by convention of a REST API, then everything is just your usual HTTP requests. So here we can say HttpApi client.make. We pass in the API that we want to implement, so the main API, and then we can pass in the options. So what the base URL is, and also an optional transform client function where we get access to the HTTP client, and so we can apply retry policies. So in this case, retry transient for 3 times. So this will retry on network connection errors and the like. And you can also apply, or rather compose your requests. So you can say http client.map request, and then here you get access to the HTTP client request, and then you can say HTTP client request.prepend URL. You can set a header, set headers, set URL param, etc., which is super handy for, let's say, appending a token for all requests. Anyway, what this is going to do internally is obviously extract all of the type information from this domain API, but also extract the schemas. So when we call todos.get, it is going to use that schema defined in the contract to decode the response body. And same thing with the payloads. So it is going to encode it behind the scenes. And that's it. As you can see, use create to do mutation, simply use effect mutation. We take in the payload to create the to do. We flat map the API client. We call create. We pass in the payload. And then here we can tap the success. So as you can see, we get the created to do here. And then we can modify the cache of this query. So you can say set data, and then we append or prepend the created to do. And this is all via these helpers that I created. And notice how my wrappers have this Toastify success, where you get the success data here. So as you can see, success is of type to do. So if you want to derive a message from that or whatever, but it's optional. Obviously, you can simply do a constant function that will always output to do created. And we do this same thing for all of the other ones. So to do updated and to do deleted. And that way, whenever this mutation succeeds, it is going to toastify this message. And same thing with errors. We have toastify defects. So we can say true or false or a custom message. So if there's a defect, it is going to toastify this. Or you can say toastify errors, which is for the expected errors. So here we have HttpApi decode error, we have parse error, we have request error, response error, and finally we have or else semantics. So for example, if I come here to the use delete mutation and then toastify errors, here I get to do not found error. How nice this is, incredibly type safe. And then here I can get the error and we can say error.message. And as you can see, error is of type this union, which is wrong. I just realized this error. I need to extract the tag by the error. So we only get to do not found error. So by the time you're watching this video, this should be fixed. But anyway, here you can also override the message, or well, rather you can return whatever you want. So you can say to do not found. And this ultimately is a callback. So you can maybe update state here, you can do whatever you want here. And if you take a look at the signature for use delete to the mutation, you'll see that it succeeds with void, nothing, but it fails with a query defect, an HttpApi decode error, to do not found, parse error, and HTTP client error. That means that if I search for this and come here, we can say delete to do dot is error. If so, we can say error, and as you can see, the error is this type right here, which is super nice. You can show an error message in your components, or maybe render X component if we get Y error, etc. And that's it. That's pretty much everything. Now I did create an integration for TanStack form. So if I search create to do or add to do, you'll see that we have use form from TanStack React form, which is a really nice library. It has some bugs, but it's more ergonomic compared to React hook form. But anyway, here I have these make form options where I define the schema, then the default values, which must conform to the encoded type of the schema. And then you can define what type of validator. So unblur, unchange, or unsubmit. And this conforms to what TanStack form expects. So as you can see here, I have this utility validate with schema. We're going to decode either passing in the schema and then the value. So the value of the submission. And then we map the errors. We format them into this object where the keys are the path of the error, and then the value of that key is the message of the error. And we also handle the root. message. So if you have a top level filter, then you can access the error message like this. And then we flip this, and then we say either.get or null. Now I know standard schema exists, but it's very clunky, and I also got some type errors from using some internal stuff and whatnot, so I decided to just create my own. And I also created this pretty much identity function, make form options, that conforms to what TanStack form expects, where we handle the specific validators, so on submit, on change, on blur, etc. And this allows you to have this type safety. So you can say form.state.errormap and then unsubmit. And as you can see, this is a schema validator result, where it might be undefined, and if it isn't undefined, then we can get access to the title, which is a string or undefined. And with this, you can say unsubmit, we decode the payload, because we assume that we're going to handle the encoded values. So for example, the encoded could be a string, so we can decode it to get the date representation of that value. And then we say mutate async, and then once this is successful, we reset the form. And again, all of this is handled via TanStack form. And that's pretty much it. That's how you can bridge the two. If you're interested in how my wrappers work, then you can come to effect query, this file right here, and you will see how everything is composed behind the scenes. So we have a use runner that handles the toasts, handles the success case, and throws the corresponding errors. And as you can see, if it isn't an expected error, then it's going to squash everything into a query defect. And yeah, here you can find the wrappers for use effect mutation, use effect query, and finally use effect infinite query. So make sure to clone this repo, play around with it, and if you have any questions, make sure to leave a comment. Anyway, I hope you enjoyed this video. I'll see you in the next one. See ya.